Okay, so these are the reactions that nitrobenzene can do now that we've taken benzene and converted it to nitrobenzene with electrophilic substitution. There's a two-step pathway to convert nitrobenzene into something called phenylamine, which can also be called aniline. One of the reactions is a reduction reaction, but the whole process is called the reduction of nitrobenzene to phenylamine. So in the first process, we're going to take that nitrobenzene, we're going to replace those oxygens on the N with a bunch of hydrogen. So we're losing oxygen, we're gaining hydrogen, that's reduction. The oxidation state of the nitrogen changes from a +3 oxidation state to a -3 oxidation state. So it's a change of 6 in oxidation state going down. The reducing agent in this reaction is tin, and so the overall reaction is C6H5NO2 plus tin, and then C6H5NH3 plus SN2 plus. Now each tin is losing 2 electrons as the reducing agent, so I'm going to need 3 of those to balance the 6 electrons gained by the nitrobenzene. We can also see that there's an O and H change, and so I have to balance out oxygen on this side with 2 waters, and in total there's 4 and 3 H's, so 7 H plus on the left-hand side. So it's an overall redox reaction, Norso reaction, with an additional condition of reflux to help this reaction take place. So the 2 reactants are concentrated hydrochloric acid to provide the acid, and tin to provide the reducing agent, and reflux to ensure that the reaction goes to completion, as well as usually with reflux, you're also heating to encourage the reaction. The second reaction is actually just an acid-base reaction. We have this C6H5NH3 plus, and we're just going to take off that H plus, that extra H plus, and we'll end up with C6H5NH2, which is the phenylamine, so a phenyl group plus an amino group. So the overall chemical reaction is just to take away that H plus, which is like acid, which is like an acidic proton, so let's just react it with base. So if we react it with OH minus or something like NaOH, then we'll be able to pull that extra proton off of there. The OH and the H plus will combine to form water, and we'll have our phenylamine final product. So the second reaction is quite simple. It's really an acid-base reaction, no other conditions needed, just knowing that the other reactant is hydroxide or sodium hydroxide. Those are the main 2 reactions. Those are the only 2 reactions you need to know for nitrobenzene and how we can start at the nitrobenzene and end up at the phenylamine in 2 steps. There's like one other reaction that is listed in SL. So it's in the first video about benzene reactions where you can substitute chlorine onto benzene to make chlorobenzene. But I've never seen that asked about on the HL exam. And benzene could also react with bromine via the same mechanism as it does with the chlorine if you have bromine and this aluminum bromide in dry ether. So benzene can technically react with bromine, just like alkenes react with bromine or alkanes react with bromine, but all by different mechanisms. So I would say these details are probably the least relevant and important details. This is the reactions of nitrobenzene that I was meant to focus on in this video.